So hi, my name is Firas Abasiri and my partner's name is
Zia Kala,
and today we're going to talk about cold water diet plan.
plan.
So the question to the problem is estimate what volume of cold water you would need to drink to overcome the effect of eating one donut. And does the amount of work done while lifting that pot of water affect how much you drink? So before stating our hypothesis, water is very beneficial for many reasons, as you guys know. It can help you digest the food faster, and it's also very important to drink cold water before every meal. So by saying that, we still think that the amount of water will be excessive, and drinking cold water in general is not enough to lose weight. It is good for you, but it won't be enough to lose weight.
Alright, before we go on to start the calculations and going through everything, we have to state the values first that we need. So, we're going to say that the water we're going to be drinking will be at 0°C, really cold. The body's operating temperature, we say, is roughly 37°C, give or take. And, the donut that we'll be eating is 300 calories, which is also equal to 300,000 kcal when we convert from the lowercase cow to uppercase cow.
So we're going to use the 300,000 kcal in our calculation to solve for the mass.
That's true. Nice one for us.
So what equation are we going to use to determine how many liters of water is needed? So the first one is Q equal mc delta T, and the unit says in joules per gram degrees Celsius. And work is equal force times distance. And the final answer will be in joules.
Now that we're going to set up the equations, we're going to have one equation represent for the energy of the donut and another equation to represent the energy of the water. We're going to set these two together in hopes to solve for m of the mass of the water. Because we're doing this, the reason why we're setting them up together is because we want to find the amount of water needed to overcome the the energy required for the donut. Hence we have Q1 is equal to Q2. Next, once we solve for that, we're also going to consider the work required in lifting the amount of water that we need is going to be any help to us. Hence we're going to use the equation W is Fd, where the F is the force needed to lift, and D is the distance that we're going to lift the water to the mouth. And for F, we're going to use newtons, obviously, because 1 kilogram of water is 1 meter and is 9.81 newtons. First things first, we want everything in standard units. Again, we're going to have to convert the kcals, which is each kcal is 4,184 joules. So when we convert Q1, the energy of the donut, it's roughly about 1.25 million joules. Setting that equal to Q2, we have mass, which is the unknown for water, times the specific heat, 4.186, times delta T, which is 37 degrees, as we have stated earlier. Rearranging for M, you get about 8,000 grams. Is that right for us? 8,000 grams?
Yes.
Yeah, 8,000 grams. When you convert that, 1 kilogram is obviously 1,000 grams. And so since we have 8,000 grams, it's going to be 8 liters, sorry. 8 liters. Now that we have found that, 8.1 liters, that's quite a bit of water, isn't it? Yeah, that's quite a bit. Now we're going to go on to solving for work. W is Ft. Since we know it's going to be 8.1 liters, it's going to be 8.1 kg. So you multiply that by the 9.81 to get the force, which is 78.4 newtons. And now we're going to say roughly that the distance needed to raise the water from the table to the mouth is about 0.25 meters. And so multiplying them together, it's about 19.6 joules.
So as we answered to the question, it requires 8.1 liters of water to digest a 300 calorie donut.
Can you drink that much?
it's you can do it, but it's gonna require so much time.
I don't think I can drink that much.
So and that, as you can see in that picture, that's a 1 liter of bottle of water. So you need to drink 8 times of that to digest a 300 calorie donut. So the reason of drinking that much of water is because a donut has an energy of 1.25 million joules. And when you drink the cold water, which is at 0 degrees Celsius, into your body temperature, which is 37 degrees, it's going to require so much energy to convert that 0 to 37 degrees. And for the amount of work done, it's 19.6 joules. So going back to the question, does the amount of work done when lifting the bottle affect how much you drink?
Definitely
the answer
no.
is no, because 19.6 joules compared to the 1.25 million joules is actually useless.
Completely negligible. On to the conclusion now. What can we draw from this, from our results? Even though the amount of water is reasonable, it's excessive, just as we have hypothesized. 8.1 liters. I don't think I could drink that. I don't think you could either.
I can't.
I don't even know if the car even takes that much petrol. 8.1 liters of petrol in it. No. And just drinking water alone is not enough to lose weight. You have to do exercise. You have to do a diet plan. You have to do all kinds of things.
But you guys, of course, you have to drink water every day and before every meal, which is very important. But our objective today is to show you guys that drinking cold water in order to digest any kind of food, it's gonna require so much water. So
much water, and so at least it will help in losing weight, but it's not enough alone to lose weight on its own.
guys, don't eat donuts.